In this video we're going to look at the comparison test. Let's get right in and state it now. So this is the test. Let AK with K greater than or equal to P and BK with K greater than or equal to Q be two sequences where K is greater than or equal to P. We'll see the importance of that in a minute. And then suppose that the series from K equals Q to infinity, or the sum from K equals Q to infinity of BK converges, and we can find some M, and for some positive M, so some constant M, we've not got some real number M. If we can find an M such that the modulus of AK is less than or equal to BK, MBK, MBK for K greater than or equal to Q, then we can say that K is equal to P. Then K, the sum from K equals P up to infinity of AK converges, and not just converges, converges absolutely. I'm not going to explain this, I'm not going to prove this, but I'm just going to sort of run through some of the logic of it. First, with K greater than Q, it means that we don't have to consider all of the terms in the sequence A, just the ones where K is greater than or equal to Q, because of a result we proved in the other video, that the initial terms of a sequence don't contribute to whether it converges or diverges. So that's nice. So we can just look at the terms AK that correspond to terms in BK, and then also so we know BK converges here. So if the modulus of AK is less than some constant multiple of BK, because a constant multiple of a convergent series also does converge, so we can just take that out, and then we've got if BK converges, it converges to a real number, so we've got a real number times a real number, that's still a real number. So and of course that's just some sort of verbal explanation. It's not a strictly mathematical well-formed argument, but the point is just to try to get your head around this intuitively, that AK, if each AK is less than BK, MBK and BK converges, well, it makes sense that AK would also converge. And then to remember the absolutely, I mean, I would just say we're thinking about this as a modulus, and if you remember our definition for absolute convergence, that also involves the modulus, so you just that's a way to remember it, not really some sort of justification. That's it for now. We might look at some examples in the next video, and of course we'll look at some more tests. We will be proving some of these tests, not all of them, just to give you an idea of how you can go about proofs. But most of this series is just going to be going through the tests, seeing how we can use the tests, and yeah, just finding different ways to see if series do converge or diverge. That is it for this video. If you did enjoy, please be sure to like and subscribe. If you got any questions, let me know down in the comments, and I hope to see you